Hello viewers, welcome to my channel. If you haven't yet subscribed to my channel, do subscribe it and do not forget to like and share the video, and do press the bell icon near the subscribe button so that you get the notifications of my latest videos. In today's video, we'll be learning about the continuation of this chapter, light, reflection and refraction, and this belongs to the chapter 1 of physics and chapter 10 of NCERT. In today's video, we'll be particularly learning about mirrors. So first of all, what is a mirror? A mirror is a highly polished surface, a mirror is a highly polished surface that reflects most of the light that falls on it. Mirror is a very smooth, a polished surface, and it reflects most of the light that falls on it. That is the reason we can see ourselves in the mirrors. Mirrors reflect the light that fall on it. Okay. Now we have different kinds of mirrors. Okay. The two main types of mirrors are plane mirror and the curved mirror, and the most commonly used curved mirror is the spherical mirror, about which we'll be learning in detail in this chapter. So first of all, let me tell you about plane mirrors, then I'll move ahead to spherical mirrors. Alright, now what is a plane mirror? See, I've drawn a diagram over here. A mirror in which we see ourselves every day, which we use regularly in our homes. In everybody's home it is available. That is the plane mirror. Okay, that is a plane mirror. You see, this is a person and this is a mirror. Just imagine this to be the mirror and the image obtained over here. This is the image obtained over here. Okay, now what is a plane mirror? See, with this name itself you can understand that a mirror that has a flat reflecting surface, is known as a plane mirror. You see that your mirror, the mirror which you use every day, is flat. It is flat. It has no curves and all. It is flat. So those mirrors which have flat reflecting surfaces are known as plane mirrors. Now let me tell you the two kinds of images generally formed by mirrors, so that you can understand whatever I'm going to teach now. First is the types of images. First let me tell you types of images formed by mirrors. Okay, types of images formed by mirrors. First, let me tell you about the real image. Okay, real image. So real images are those images which are formed in front of the mirror, and it can be obtained on the screen. Real images are formed front of the mirror, and the second thing is that it can be obtained on a screen, and the most special thing about these real images is that they are generally inverted. Real images are inverted. They are formed in front of the mirror, they can be obtained on the screen, and they are inverted. This is the first type of images that is formed by any kind of mirror. Alright. Now the second kind of image that is generally formed by the plane mirror, the mirror in which you see your face, your beautiful face every day, front of which boys do their hairstyle and girls do their makeup. That is a plane mirror, and there you obtain your virtual image. Now the characteristics of virtual images is that virtual images are formed behind the mirror. Okay, I told you about real mirrors, they are formed front of the mirror, but in plane mirrors the image is formed behind the mirror. Okay, behind the mirror. And real images can be obtained on the screen, but virtual images cannot be obtained on the screen. So cannot be obtained on a screen. And virtual images are always erect. Real images are inverted. If the image is like this, I'm telling you about real image, if the object is like this, then the image formed will be like this in case of real mirrors. If the real mirrors form the image, then the image will be like this. But in case of a virtual image, if you want to know what is a virtual image, say for example let the object be this. This is the object. Then virtual image will be erect like this straight. So these were the types of images formed by mirrors. Now I will tell you the characteristics of image formed by plane mirror. The mirror in front of which this boy is standing. Plane mirror. So the first characteristic of the properties of image, the first characteristic of the image formed by plane mirror is that it is always virtual. The image is formed behind the mirror. Second characteristic or the second property is that I already told you that virtual images are always erect. So it is erect, or you can write virtual and erect together if you wish. Then the third property is that the size of the image is equal to the size of the object. Okay, so image size, I'm writing it in short form. Image size is equal to object size. When you see your image in the mirror, do you see your head is big, your eyes are big than the normal than your normal size? No, it is of the same size. Then the fourth property is that the image is formed as far behind the mirror as the object is in front of it, which means if you're far from the mirror, then the image will also appear to be far. If you're so close to the mirror, the image will also be so close to you, which means the image distance is equal to the object distance. And finally, the image formed by plane mirrors are laterally inverted. Very important point. Laterally inverted. You have observed, I hope, in mirrors that if you raise your right hand, your image will raise your left hand. See, he is raising his right hand. The image is raising his left hand. This is known as lateral inversion. You see his hairstyle this way over here, but in the image his hairstyle is like this. This is known as lateral inversion. You can see this in plane mirrors. Now I will tell you about spherical mirrors or curved mirrors. Spherical mirrors are the most commonly used curved mirrors, or the most commonly used curved mirrors are spherical mirrors. Now particularly I will be teaching you about spherical mirrors. Okay, now spherical mirrors. From the name you can understand spherical, sphere. So spherical mirrors are a part of the sphere. Consider this to be a sphere. Okay. Now I take a part of this sphere. Alright, I take a part of this sphere. And let my inner surface be the reflecting one and the outer be the rough surface. This is a spherical mirror. I take another sphere, okay, and I take a part of it. I take a part of the sphere. Let the reflecting surface be outwards. Let it be outwards. This inner surface is the curved one. Excuse me, actually there was a power cut over here. Alright. The rough surface is inside and the reflecting surface is outwards. Spherical mirrors are part of the sphere and their reflecting surfaces are curved inwards or outwards. So spherical mirrors are of two types. One is concave mirrors, another is convex mirrors. Concave mirrors are those mirrors whose reflecting surfaces are curved inwards. So this is your concave mirror. And convex mirrors are those mirrors whose reflecting surfaces are curved outwards. So this is the convex mirror. Alright. This is a concave mirror, the mirror whose curved surfaces is inward, the mirror whose reflecting surface is curved inwards. Just remember this word, cave, inwards. So you can remember that in concave mirrors, the reflecting surface is curved inwards. Now convex mirrors, the reflecting surface is curved outwards. Now let's go for some important terms related to spherical mirrors. Without these terms you cannot proceed ahead, so I'll tell you those terms, whatever term is required to know before you learn in detail about spherical mirrors. So the first one is, the first important term which is related to your spherical mirror is the pole. Now let me draw the diagram and show you. This is my your concave mirror. The reflecting surface is curved inwards, so I should draw my rough surface where? Outwards, because here it's a reflecting surface and here is the rough surface. Here no kind of reflection will take place. So I draw my rough surface outwards. This is a concave mirror and here I take another convex mirror. I told you in convex mirrors the reflecting surface is curved outwards. So where I should draw my rough surface? Inwards, because no reflection will take place inside, only reflection will take place outside. So I draw my rough surface outside. Okay. Now what is a pole? The pole is the center of reflecting surface of a spherical mirror. It is a point. The center of this reflecting surface is a point and this point is known as the pole and it is represented with the letter P. Over here the center of reflecting surface of this mirror is a point and it is known as a pole, and I express it with letter P. Okay, this is the pole. Now the second important term related to spherical mirror is the center of curvature. Now it is the center of curvature. Center of curvature is generally denoted with the letter C, capital C. Now again, let this diagram be here. This is the concave mirror and this is the convex mirror. Now the center of the sphere, I told you this is a part of a sphere, right? This is a part of a sphere. So let me draw it with dotted lines. Now this is a sphere. You know that sphere has a center. This is the center of the sphere. For this sphere, this is a center. Now let me define center of curvature of any spherical mirror. The center of the sphere, okay, the center of the sphere of which the reflecting surface of a spherical mirror is a part is called the center of curvature. Okay, now erase these dotted lines, which means I erase this sphere, whatever is not needed. Now I take only the mirror. This is the center of curvature. Okay, C, center of curvature. The center of the sphere of which the reflecting surface of the spherical mirror is a part is known as center of the sphere. In case of concave mirror, the center of curvature lies in front of the mirror. Okay, in front of the mirror. But in case of convex mirror, the center of curvature lies behind the mirror, because this is the reflecting surface. This part here, this is the rough surface. So here is your center of curvature. This lies behind the mirror. Center of curvature is not a part of reflecting surface. Center of curvature lies either inside the spherical mirror for concave mirror, or it lies outside the spherical mirror if your spherical mirror is convex. Now your next important term related to your spherical mirror is the radius of curvature. The next important term is the radius of curvature. Now this is the center of curvature, right? You know what is radius. Now if I join this becomes the radius. Radius of curvature of spherical mirror is denoted by the letter capital R. This is the radius, okay? This is the radius of this concave mirror, radius of curvature of this concave mirror, and this is the radius of curvature of the convex mirror. Alright. Now another important term related to spherical mirrors is the principal axis. Now principal axis is an imaginary line. The principal axis is an imaginary line that passes through the center of curvature and pole of the mirror. Okay, principal axis is like this. It passes through an imaginary line that passes through the center of curvature and pole of the mirror. Even here it is the same. It is just an imaginary line, but the condition is that it passes through the center of curvature and the pole. Here also you see center of curvature and the pole. It passes through the center of curvature and the pole of the mirror. Another thing, an important thing to note is that the principal axis The principal axis is normal to the mirror. It is the normal to the mirror at the pole. You know what is a normal, right? It is normal is the perpendicular line. So this is normal to the mirror at the pole. Even here your principal axis is normal to the mirror. At the pole it is normal. It is normal to the pole of the mirror. Now another important term again you have in this terms related to spherical mirrors, that is principal focus. Focus or principal focus, okay? Principal focus of the mirror, principal focus. Now principal focus means it is a point on the principal axis, a point on the principal axis at which many parallel rays, which they can come from infinity, many parallel rays after reflection they converge at a point. Okay, now let me draw the diagram clearly so that you can understand better. First I'll take a concave mirror and show you, then I'll show you with a convex mirror. Okay, your concave mirror is something of this kind. Let me draw it in the center. Your concave mirror is something of this kind, right? Which is a reflecting surface inward. So where is the rough surface? Outward. I am drawing a concave mirror now, okay? Then which is the pole? The center of reflecting surface is the pole. This is my pole. Okay? And this is the center of curvature. Alright? C. This is the principal axis, an imaginary line that passes through the center of curvature, and the pole of a mirror is the principal axis. Now I take an object, say this is the object which is at infinity, okay, it is at infinity. Now many rays, a number of parallel rays, to which it is parallel? It is parallel to the principal axis. They all fall on the concave mirror, okay? They fall on the concave mirror. This is a ray. Then I take another ray like this. It falls on the concave mirror. Then I take another ray like this. Now the incident on the concave mirror. Now after reflection what happens? They all meet at a point on this principal axis. This is the principal axis, right? This is your principal axis. They all these rays meet at a point. They meet at a point on this principal axis. Now when they reflect, what happens? They'll get reflected like this. Okay? Again another reflection comes like this. This ray gets reflected like this. You see, they meet at this point. This point. So they get reflected. This point is known as principal focus, F. Principal focus is denoted with the letter F. F. Okay. So, how would you define it? A point on the principal axis at which parallel rays coming from infinity converge after reflection is known as principal focus. Now in case of concave mirror, all these rays meet in front of the mirror because it is curved inwards. So concave mirrors are known as converging mirrors because they all converge at a point. So another name of concave mirror is converging mirror. Alright, now I'll draw it with the help of a convex mirror. Okay, in convex mirrors what happens is these rays I'll draw it and show you. This is your convex mirror, and in convex mirror, which is the reflecting surface in convex mirror? In convex mirror, your reflecting surface is outside. So where I should draw the rough surface? Inside, here. Because this is a rough surface, here no kind of reflection takes place. This is a convex mirror. I take an object at infinity. Before that, let me draw the pole. Okay, your center of curvature C, and your principal axis, an imaginary line that passes through the pole and the center of curvature. This is the principal axis. This is your object at, where is it? It is at infinity. It is at infinity, alright. Now, a number of rays from this object incident on this convex mirror, okay? And these rays should be parallel to the principal axis. These rays should be parallel to the principal axis. Another ray comes this way and it incidents on the convex mirror. I take another ray again, incidenting on this convex mirror. Now what happens is that these rays, after reflection, you see it reflects like this, okay? It reflects like this, gets reflected back. But it appears to come from somewhere in this point. Again, this incidenting ray, this ray gets reflected like this, okay? But it's somewhere, it is appearing to come from here. Again, this ray, it is reflecting back like this, okay? But it seems to come from this point, right? These all imaginary lines meet at this point, right? So this point is known as a principal focus. Now in case of convex mirror, your principal focus lies behind the mirror. But in case of concave mirror, which just now I showed you, in case of concave mirrors, principal focus lies front of the mirror. Now you see that in convex mirror, your reflected rays, you see it goes like this, it goes like that. They all diverge. They diverge at different places. So convex mirrors are also known as diverging mirrors. They are also known as diverging mirrors. Hope you have understood what is principal focus. Now the distance between the pole of a mirror and the principal focus of the mirror is known as focal length, and it is represented by the letter small f. This distance between the pole and the principal focus is known as focal length. It is represented by this letter, small f. Again, in case of concave mirrors also I showed you, in concave mirrors, the principal focus lies front of the mirror. So again there, let me show you the focal length. This is my concave mirror, rough surface. Okay, this is the rough surface. This is the pole. Always after drawing the mirror itself, draw the rough surface wherever is the rough surface, just because you should be knowing which is the reflecting surface. So soon after you draw the mirror, just draw the rough surface. After that, just mark the pole, mark the center of curvature, draw the principal axis. Alright, this is your this is your object. This is the object at infinity. Okay, a number of rays parallel to the principal axis fall on it. I am just drawing 2 rays for my convenience, so that the diagram becomes easier to understand as well. They meet at a point After reflection, they meet at a point. This is your principal focus, I told you. Now, the distance between the pole and the focus over here, it is the focal length, F. In case of concave mirror, the focal length is over here. But in case of convex mirror, I showed you where was the focal length. And finally, one more term you have is that aperture. Aperture means the diameter of the reflecting surface of a spherical mirror is known as the aperture. Your concave mirror, this is the rough surface of the concave mirror, and here's my convex mirror, this is the rough surface. Aperture means the diameter of the reflecting surface of the spherical mirror is known as aperture. Now, now your terms are over. Terms related to spherical mirrors are over. But you have a relationship between the radius of curvature, that is denoted by the letter R, then your focal length of a spherical mirror. There is a relationship between these two in any spherical mirror. For spherical mirrors, the radius of curvature is found to be twice the focal length. This is an important relationship between the radius of curvature and the focal length of any spherical mirror. That is, the radius of curvature is twice the focal length, or your focal length is half the radius. Both are right. If your radius of curvature is, suppose I tell you one sum, okay? Your focal length is 5 centimeter. Say for example, your focal length is 5 centimeter. Then how much should your radius of curvature be? It should be twice this focal length, right? So we know that R is equal to 2F, which implies R is equal to 2 into 5, which means radius of curvature is 10 centimeter. Okay. Now suppose I am giving you a sum where radius of curvature is 20 centimeter. I tell you, find the focal length. Focal length is equal to 20 by 2 and your focal length becomes 10 centimeter. This is how you should apply this relationship between this radius of curvature and the focal length of the spherical mirror. This is the relationship between these two. Now I told you that it is this focal length is twice the radius of curvature, right? It means that your focal length or your principal focus is between the pole and the center of curvature of the mirror. Suppose this is the pole and this is the center of curvature, principal axis. After the rays, after incidenting, they get reflected back. They reflect back and they meet at this point. This is principal focus and this is small f. That means focal length. This relationship that R is equal to 2F also implies that principal focus lies midway between the pole and the center of curvature. This is in case of convex mirror. In case of this is in case of concave mirror, and in case of convex mirror, how would it be? In case of convex mirror, it is like this. Here is my pole and here is my center of curvature. This is the principal axis, and after divergence they appear to come from this point, principal focus. This is small f, that means focal length. Over here, this principal focus appears to be between the pole and center of curvature. What is this between the pole and center of curvature? This is radius. I end my video over here. If you have any kind of queries or any kind of doubts, do ask me in the comment section, or if you want me to make a video on a particular chapter, even that do ask me in the comment section. Goodbye.